Welcome to E-Padasala PG students of Computer Science. Today we will be looking at the embedded system 8051 architecture in detailed way. So, in this class we will be covering about the detailed architecture of 8051 controller, and we will be looking at the register banks of 8051, and 8051 has special purpose registers that will be covered, and the other than the registers we will have a memory, timer and interrupts, so many things inside 8051, and all those things we will be covering in this lecture. So, this is actually the overall detailed architecture of 8051 microcontroller. In this we will be looking at basically in all the controllers we will be looking at the ALU. This does the processing. Here also we have an ALU where the input is coming through accumulator and another register. So, we have two temporary registers through which all the data, whatever be the thing which has to be processed, will be sent, and one of the operand is always coming through accumulator only. The accumulator is given over here as ACC, and this is always available with all the controller architecture, and we have a B register also. So, this B register also holds sometimes the operands. That means for multiplication and division we will be using this particular register, where we will be having a memory here, random access memory and read only memory is there, where we will have all your special purpose registers which are available over there. This is very important, where this may not be looking similar in other architectures. In this 8051 we have PCON, SCON, TMOD and your interrupt register, enabled register, serial communication. For assisting serial communication SBUF, and we will have timer registers. So many registers is also available. We have other than that we will have something like 4 ports, P0, P1, P2, P3. So, 4 ports are available. All these 4 are having 8 bit communication line. So, parallel ports are available, and we will be having something like oscillator. This oscillator provides clock for this particular CPU, which in turn synchronized with machine cycle. So, the machine cycle is synchronized with the system clock, which will be given by this particular oscillator, where we will be having a RAM, address register. This is actually address register through which only all the RAM address will be sent, and the data will be communicated through this particular line bus, and it will be going through all these things. And we will be having a general purpose registers also over here, which was not shown over here, where we will be having a 8 bit 8 number of registers. Register 0 to register 7 is our general purpose registers, which is also available, and we will be having, these are all special registers where I can call this is DPTR, where this is interfacing the memory address for the external memory. Sometimes we will not be using the memory which where that means we will use this RAM and ROM. If this is not sufficient, we will be using external memory. So, that particular external memory is accessed through this DPTR. So, the memory address will be sent through this DPTR, because the DPTR has 16 bit address. So, 2 registers combined together. So, 16 bit address will be sent through this, where we will be having a program counter. This will be used for holding the address for the next instruction, where we will be having a PC incrementer. So, each time when I am getting an address, I will go and I will fetch the data, and I will come over here for data or instruction, and this will come to my instruction register. So, from the instruction register, the instruction is getting decoded, and the timing and control unit will send control signal to all the parts of this particular architecture. All units receives control signals from this particular part, where this program status enable as well as your ALE address latch enable and external access EA and reset, all these things are connected through this particular control unit of this architecture. And where we will be having something like your buffer, sometimes the serial buffer is used for serial communication, and the program address register, which will be is the interface. If I am providing the PC, what will be the instruction address which comes to program address register, from there onwards it goes to ROM, random access memory, and the instruction is read and it comes through this particular path. This is the bus and it comes to instruction register. So, when I am looking at the whole architecture, I will have, the last class we have gone through a simple informations, but now we will be looking at what is inside over it and how this process has been done through this particular architecture. So, we will be looking at in detail how these things will be done. Okay. So, when I am looking at, as I told you, the general purpose registers, we have 8 general purpose registers where we will have R0, R1, R2 up to R7, and all are 8-bit wide. So, when I am looking at 8-bit wide, these registers are general purpose registers, all the data as well as address, what will be the thing which will be stored over there while we are processing any instructions. And these are used as a scratch pad where you can move data, you can move address, what will be the thing you can use it. And these are all used, that is what they are trying to say, either I can use it for data storage or I can use it as pointers. That means address will be stored when you are looking at indirect addressing mode. And accumulator is a very special register which will be very important when I am looking at ALU. So, whatever be the process I am doing it, one of the operand is always available with your accumulator. It has to go through only accumulator. It will be always referred as A over there, or either ACC or A will be referred, but when you are writing an assembly code, it will be referred as A. And holding one operand and one operand in arithmetic and logical instructions. Whether it is logical or arithmetic processing, this accumulator holds one of the operands, and it is as usual it is a 8-bit wide register. When I am looking at B register, this is also a very important register for your processing. Usually for in the arithmetic, for your multiplication and division operations will be one of the data will be stored in your B register, and the other instructions can be treated as another scratch pad for the. This is actually similar to like your A register only. It is also used as a scratch pad register. This is also 8-bit length, as this 8051 is of 8-bit processor. It will have all the registers which will be of 8-bit length. But when I am looking at a program counter, this is actually a 16-bit length. That means we will be having I can hold a 16-bit of address over there in my program counter. So, if it is 16-bit, maybe if I am referring a memory where it needs only 8-bit, that also can be accommodated, that also can be placed inside my PC because it is having a 16-bit length. The address of the next instruction to be executed will be available always with your program counter. Usually this will be called it as PC over there. And when you are looking at your program status register, where this is a very special purpose register, as the name itself tells you that PSW is nothing but program status word. That means this status word is stored in your PSR. That means program status register holds this PSW, and it is 8-bit wide, and what is the information will be holding it over there is if currently a particular program is running and the system, what is the system is executing in which state will be inferred by this particular register. That means it shows the status, where I can tell you the first bit, that means the 8th bit MSB bit, which will be telling you if it is 1, then I will say that the carry is there. So, I can call this as PSW.7, this particular bit, and this is a carry bit. When this is otherwise called it as a carry flag. If there is a carry overflow, then if there is a carry occurs while I am doing a processing, then this bit will be this bit will be set as 1. When I am looking at the next bit, that means PSW.6, which will be auxiliary carry. So, if there is a overflow in the 4th bit, if I am adding 2 numbers where there is a overflow at this bit and it comes as a carry over here, then there will be a auxiliary carry. And the next is your flag 0. So, when I am processing a data, if there is a result is getting a 0, then this flag will be set as 1. So, this is otherwise called a 0 flag, and we will be having a register bank. So, when I am looking at my R0 to R7, so 8 registers are there. what are all the address through which we will be using that particular registers will be decided by this RS0 and RS1. This is a combination. So, I can make 2 bits. So, 00 to 11 I can make it. Rather you can look at over here 00 will be the bank 0, the address for your R0 to R7 is 00 to 07, whereas 11 means bank 3 where 18H to 1FH. So, this will be the place. So, based on what is the value I am putting it over here RS0 and RS1, which tells you about where your register is getting stored. So, you remember that when I am looking at a register, this is also a memory place where I will be storing all my data set. And OV is nothing but overflow flag. If I am adding two numbers, is there any overflow is there? That was I mean during that particular operation, during the result, if I am getting a overflow, then this particular flag will be set as 1. So, overflow flag. So, and this particular bit is reserved, and the last bit is your parity bit. So, odd parity or even parity, based on that this bit will be 1. So, this program status word tells you about currently what is the status with which the program is running in your processor. So, based on that I can predict what will happen, and what is going on inside my processor. This is the idea behind this particular program status word. And the next important thing is your stack pointer. So, as we know that the stack operations are very important with the processors, here the stack pointer is there. It is just like a pointer which points about the address of the stack top. So, when you are looking at the stack pointer, which is also having a 8-bit wide, and it is incremented before the data is stored during push and call executions. That means the push and call is your stack operations. By the time when I am doing this particular process, by the time I wanted to have something like the address is either incremented or decremented. So, that has been done with your stack pointer. So, it may reside anywhere on chip RAM, and the stack pointer is initialized to 07H after a reset. This causes the stack to begin to the location 08. So, as I told you, this is a pointer which points to the stack top, and this is the data pointer where as I told you, this DPTR is nothing but a data pointer which consists of two registers, one is DPH, another one is DPL. So, DPH and DPL is combined together will provide you, will call it as DPTR. So, when it is when I am using these things together, I can store 16-bit address. So, this is always used for referring, it will be holding an address, that particular address refers to the external memory. So, it is intended function to hold a 16-bit address. It may be manipulated as a 16-bit register or two independent 8 registers used as a pointer to external memory. Now, we will be having a ports. We have something like I can tell you we have four parallel ports, that particular and 2 serial communication ports. So, this parallel ports which can be used for reading data or sending a data out or reading a data from outside, or you wanted to send an address to a memory, or you wanted to read data from your memory, or you are sending it from output device to an output device or reading it from input device. So, all those things can be interfaced through this ports. So, P0 to P3 we have 4 parallel port ports are there. These are all special SFR latches of port 0, P0 to P3 are SFR latches which for the ports 0 to port 3 respectively. So, usually the port 1 is a simple IO port, whereas P0 and P1 simple IO and address bar data. That means you can use it acts like a multiplexer. That means I can use P1 and P0 together for address. I can use data also can be read over there. So, P0 and P1 together will be used for address and data communication, whereas the P3 is simple IO and multiple function. The other special functions can be interfaced through my port 3. Then the next important thing which we will be looking at is your serial data buffer. That means, if I am looking at serial communication where actually the 8-bit data will be processed in 8051 register processor, where when we are using a input device which is of the kind of sending sending a data of serial communication, that means 1 bit after 1 bit, then I need to provide an interface. The same way, if I am looking at a output device where it reads only the data a bit after bit, then I need to provide a facility for that. Because of that particular purpose, the 8-bit data in 8051 is converted to serial information like 1 bit after 1 bit, and it will be sent through or either read through this particular ports. So, pins. So, now this data, but it has to be either reconstructed as 8 bit or it should be delivered as single bit after single bit through a buffer. So, that particular buffer is otherwise called S buffer. So, this S buff is used for supporting serial communication. Okay. So, it goes to the S buff is going to transmit buffer where it is hold the serial transmission. If it is moved from, when data is moved from S buff, then it comes from the receive buffer. So, the S buff is the interface between a serial either the transmitter or receiver of a serial communication to the processor. So, when you are looking at your timer registers, we have something like 2 registers combined together, TH0 and TL0 combined together is called it as a DPTR. This is actually a timer register where TH0 and TL0 combine together to make timer 0, and TH1 and TL1 which will be combining together to make timer 1. So, 16-bit counting registers for your timer, or it can be used as a counter. So, we have either 2 timer or 2 counters using this 2 sets of registers. So, when you are looking at special function registers, so the special function registers I can call it as rather I can call this as a control registers, where we will be having IP, IE, TMOD, TCON and SCON and PCON. When I am looking at these are the special function registers, that means this interrupt enable is used for interrupt handling, and TMOD is for timer control, TCON is for when you are looking at TCON, this will facilitate towards your timer mode as well as your serial communication and your IE, all those things combined together to hold it, and SCON is meant for your serial communication register and PCON. So, when you are looking at this IP, IE, TMOD, TCON, SCON and PCON, these are all control registers to support, to enable, to activate different processes which should be handled by your 8051 controller. So, when you are looking at the IE, we will be setting a particular bit which in turn allows the system to work on interrupt. The same way, when I am looking at timers and counters, some of the bits will be set or reset with your TMOD, which enables or disables these timers and counters, and the serial port communication has been enabled through your SCON. So, when I am looking at my memory, so this memory is very important when I am looking at 8051. So, as I told you, this particular memory we will be having something like only 128 bytes. That means only 188 words can be stored with your random access memory in your 8051, where as I told you from 00 to 7F I will be in a position to hold all the data. This is the address, in that address only my data is stored, and each data is of 8-bit width. So, now when I am looking at 00 to 07, that means 8 locations which will be used for register bank 0. I will have only 8 registers. These registers either stored it in this place, or 08 to 0F, or 10 to 17, or 19 to 1F. So, based on this RS locations, RS0 and RS1 together, if it is 00 it will be, and if it is 01 this will be the place, if it is 10 this will be the place, 11 with this will be the place. So, based on that your register R0 to R7 is located in your data memory. So, I will call it as a register, but those registers also will be written or updated with only these memory locations. And from 20 to 2F bit addressable RAM, I can place data while I am doing all processing, and 30 to 7F. So, this is the major space where I can use all my data can be moved over here and I can process it. And my code also can be, see whatever be the thing I can do it with only 30 to 7F. These places maybe it is I can say that 1F to 00, 00 to 1F will be reserved for your registers. You cannot use it for storing your data or whatever be the program, whatever be the thing, you cannot store it over here. Just I can say that it is best you use memory from 30 to 7F, because these are all reserved spaces where I should not be in a position to handle it. And as I told you, the register bank and addresses, here this 0 to 7, I can tell you R0, R1, R2, R3. So, 8 registers are there. This if I am storing it from 0 to 7, that means 00 to 07, then I will say that bank 0. So, if I am setting it bank 0, then this address can be used for storing this. Maybe if I am looking at bank 1, where this will be stored from 08 to 0F. So, if it is bank 2, then R0 to R7 is placed in 10 to 17. So, these values are telling you about the memory addresses. So, this has been written in hexadecimal. So, only it has been given as A, B, C, D, E, F, then 1, this is nothing but 14, when 15, when it becomes 14 and 15, when it is 16 in the decimal, this will be converted into 10 in your hexadecimal. So, this is addresses, so which has been written in hexadecimal. So, bank 3 is from 18 to 1F. So, I told you 1F to 00, you should not use it, it is a reserved space for your register storage. So, now when I am looking at the bank selection. So, when I am looking at bank selection, as I told you in your program status word, there is 2 bits where RS0 and RS1 is there. I can tell you PSW.3 and PSW.4. This 3 and 4 is telling you about the pin number. So, PSW is telling about program status word. So, these two positions combine together to tell you about your bank selection. So, I will say bank 0, if it is bank 0, I can say that 00 is placed over there. So, 01, 10 and 11, this indicates where I will be storing my registers. So, if the data is run with my controller, if I am writing it, move the data from R0 to R1, then if these two are 00, then my system will look at the addresses 01, 02, 03, so that way. So, now the looking at the program status word, the system identifies where it has to refer these registers R0 or R1 or R2, where it will be placed. Based on that, it will go and read and it will update the data over there. So, when I am looking at ALU, I know very well people when I am looking at any of the processes, the ALU is of very important. So, I will be in a position to look at my ALU, it will perform arithmetic and logical operations. So, when I am looking at arithmetic, I need to have minimum of 2 operands. If it is addition, at least minimum 2 operands is needed. So, the data will be coming through 2 of the registers. One is through your accumulator and another one is through the another temporary register. So, these 2 are coming towards your ALU as 2 hands. Now, the processor will be dictated with doing the arithmetic operation, then it will add it. It will send the data to one particular temporary register, through from there it will go towards where we wanted to have our results. So, and when I am looking at logic, when I am looking at a multiplication or division, by the time people will put the operands in accumulator and B register. So, it has been confirmed your data will be before doing this operation, your data should be moved towards A and B. So, here A is referred to accumulator. So, the arithmetic operation is done and the results will be taken out, and this will be going towards your outputs. So, now when I am looking at increment and decrement, so not only your arithmetic, we will be looking at logical operations also. Logical in the sense I will be doing and, or, not, all those operations can be performed through your this when you are looking at your arithmetic logical unit, this takes care about your operands, processing, and results will be sent out. So, other than that, increment and decrementing the register contents is also done by your arithmetic and logical unit. Sometimes the PC value gets incremented, sometimes what will be the data which is available in your register is also getting decremented. This also can be done through your ALU. So, now when you are going towards the clock circuit, the clock is nothing but here I will be having crystal oscillator in my architecture. So, this crystal oscillator, what it does is it generates clock cycles. So, that particular clock cycle in turn assists the processor for making its machine cycles, or it is synchronizing with the other operations. Rather, I can say the clocks which will be machine clocks, or the system clock is generated through this particular clock circuit only. Basically, it is a crystal oscillator and it generates the clocks. So, the oscillator in any case drives the internal clock generator. The clock generator provides the internal clocking signals to the chip. So, the internal clocking signals are at half of the oscillator frequency and it defines the internal phases, states and machine cycles. Remember that when I am looking at a processor, I will say that I need to have 12 oscillator periods to have one machine cycle. So, what it means is, if I wanted to do a one process at a machine, it needs 12 oscillator clock cycles to do that. So, each process will be done by a system with one machine cycle, and for this 8051 controller, one machine cycle needs 12 oscillator periods. So, based on that you can you will understand that what way we will be going towards your clock cycle, clocks will be taken by your system. So, usually for the 8051 we will be having a 12 megahertz oscillator, or we will be having a 11.0592 oscillator, or we will be having a 22 megahertz oscillator, and based on what is the oscillator I needed, I will be putting it over there, and based from that the clocks will be generated, and one machine cycle, one instruction is done, one particular task with the machine is done with 12 clock cycles. So, always the synchronization is done by the processor with its only clock. So, now I have given you the overall picture about the 8051 architecture, and in depth what are all the units are available over there and how it works, and especially what are all the registers or general purpose registers are there, and how many special registers which is available with your 8051, and how it assists the processor to do the work that we have discussed. And we have discussed in detail about the program status word, and with that how we will be identifying what is the status of the processor by the time during that particular program running, that will be explained by your program status word that we have gone through. And we will be looking, we have just gone through, we have a timers as well as counters over there. But anyway, in detail we will be looking at timers and counters and all the special purpose registers. This will be how this will be helping the 8051 to do a special purpose tasks. So, this lecture refers most of the things through your Atmel 8051 manual as well as 8051 microcontroller and embedded system by Masdi book. So, these are the references you can refer in detail for what will be the thing which is covered in this particular topic. Thank you.